So we're going to start talking about polynomials. Now you see I talk about polynomial function, and this would be the definition or an example of a polynomial function, which is really, really scary. So let me make this less scary for you. So an example of a polynomial would be something like 3x to the fourth minus 2x cubed plus 7x minus 5. Okay, this would be an example. So what's happening, what you're going to notice is with a polynomial, you're going to have x's with different exponents. So this one has an exponent of 4, this one has a 3, this one has a 1. This one actually has an exponent of 0, so if you think x to the 0 is 1. So even these guys without them have an x with an exponent. And then you're going to have what we call coefficients. So coefficients are the numbers in front of those variables. And when you're looking up here at this, basically these a's that you're going to see in the front, all these a's, those are just the coefficients. Those are the 3's and the 2's and the 7's and the 5's. Okay, so it's just a general way of writing it. You know, when we have an equation of a line, we write y equals mx plus b. That way we can say that every line looks like this and there's no numbers in there at this point. We can always put numbers in for m and b. When we're looking at this one, our m's and b's are these a's right here. That we would put numbers in. These all stand for numbers. And so then what you ask about is what's a subscript? You know, you have these little n's and n minus 1's and all that stuff. Well, that's just saying that this a belongs to n, which means the exponent on the x is n. So these will always match up. If you look, these match up. Here, these match up. And if you remember, I talked about these without the x, well, that's a 0. So they match up. So that's all that stands for. Another thing I need to point out with a polynomial is that the exponents are always whole numbers. Okay, so you're always going to have a whole number there for the exponent. No fractions, no decimals, no square roots, things like that. Yeah, so this was a polynomial. So then some terms that we need to know about is things like the leading coefficient. The leading coefficient is the coefficient of the biggest exponent. Okay, so it's the coefficient of the biggest exponent. So then the leading coefficient to my example is 3. 3 would be the leading coefficient. The constant, so this next one, the constant, is the number without a variable. Okay, that's that one where the exponent is 0. Basically, because it doesn't have a variable, it stays constant. So this would be my constant, and this would be my constant. It doesn't have a variable. Okay, the next term is the degree. That is the biggest exponent. So if we look at my example up there, my biggest exponent was 4, so the degree, this is a degree 4 polynomial. And then standard form is when you line them up from the biggest exponent to the smallest exponent. That would be then in standard form, all the way down to the constant if there is one. So if you have, let's just say, a degree 0, okay? If you have a degree 0 polynomial, the name of that is just a constant. And so if we want to look at an example, 5, just having a 5. This is a polynomial. It's a silly polynomial because it's so simple. But 5 would be a polynomial of degree 0, and it's just called a constant. If you have a degree 1 polynomial, this is considered to be linear. So an example of a degree 1 would be 2x plus 7. So here the biggest exponent is 1, and in standard form we always go down from biggest to smallest. A degree 2 polynomial is considered to be a quadratic. We just finished talking about a lot of those. So quadratic would be x squared plus 3x minus 5. Okay, so that would be a quadratic. Standard form, we're going down by 1s for each exponent there. A degree 3 polynomial would be considered a cubic polynomial. So an example would be, let's say, 2x cubed plus 7x minus 1. Okay, so here you'll notice I skipped x squared. There is no x squared in this polynomial, but it's still going down by degrees. So we start with our biggest exponent of 3. So this is a degree 3 polynomial. And we can keep on going. You have a degree 4 is called a quartic. Oh, I think I spelled that wrong. And degree 5 is called a quintic. But really, our book stops here at the cubic. They don't really talk about the rest of those. The rest of those we talk more about when you take college algebra and things like that. So now we're going to look at what do we do with this. So if we look at this first one, let's talk for a second about these guys right here. You have already talked about them. You've seen them in Algebra 1, maybe Geometry. We might have even talked about them this year already. But that's notation that we're going to find very useful now as we go on. So you notice I say f of x. This just means a function where the variable we're working with is an x. And so we use f to stand for function, but sometimes we have more than one polynomial, and so then we use a different letter to say this one is going to be g of x, and that way we know which one's f and which one's g, so we can talk about them without having to say, you know, the one that says 2x squared plus x minus 6. We can just say f of x. And so if we look at this first one here, it's 2x squared, so my biggest exponent is a 2, so this is considered to be a quadratic. The leading coefficient is 2. The constant is negative 6. Now if we look at g of x, the biggest exponent is a 3, so this is a cubic polynomial. The leading coefficient is 4. The constant here is 10. And if you don't have a constant, you don't always have to have a constant, then you would just say it's 0. And if there's no number in front of the x to the whatever giving you a leading coefficient, it's going to be 1. And so now this next part is going to be really important. We're talking about evaluating. And so this notation that you see right here with the 3, instead of the x, we have a 3. What they're saying is, I want you to plug in 3 for x. I want to see what this is when x equals 3. So what we do is we take 3 and we plug it in for all of these x's. So I have 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. And then we continue on doing our math. Remember exponents first, so it's 2 times 81 minus 8 times 9 plus 5 times 3. We can go ahead and just do that. There's no other math there. Minus 7. And 2 times 81 is 162 minus 8 times 9 is 72 plus 15 minus 7. And now we just go ahead and add, subtract as we need to. 162 minus 72 would be 90. 90 plus 15 would be 105. Minus 7 would be 98. I believe I did my math right, but no calculator, so don't hold that against me. Okay, now this one says that we want to find g of negative 2. So once again, I'm taking negative 2 and I'm plugging it in for all my x's. So I have 3 of negative 2 squared minus negative 2 to the 4th minus 5 times negative 2 and plus 10. And the thing that worries me when I have you guys do a problem like this is the negative with the 2 and making sure you do that right. So remember always exponents first. So it's still going to be a 3 there. And negative 2 squared, the 2 squared is 4, and the negative squared becomes positive, so it'll be just plus 4, minus negative 2 to the 4th, that would be a positive 16. The 4 you have 4 negatives, cancel out. Negative 5 times negative 2, there's no other math there, so I can go ahead and just multiply that's plus 10, and then plus 10. I want to point out oh shoot, okay, I copied that down wrong. This is supposed to be a 5, isn't it? So let me do some erasing here. Alright, so that's supposed to be a 5, not a 2. So I'm going to go back. This is times negative 32 then, because negative 2 to the 5th is negative 32. Alright, then we have 3 times negative 32 is negative 96 minus 16 plus 20. I'm just going to go ahead and put the 10s together. So negative 96 minus 16, that would be a negative 112 plus 20 gives me, let's see if that would be negative 92, I believe. I hope I did my math right there. I know this is getting to be long, but it's really important that we go through all of this. So now I want to talk about these 3 equations here, or these 3 things we're trying to answer here. If we have 3x plus 2x, I want to point out those have the exact same exponents. It's x and x. So we can go ahead and add them together. This is saying I have 3 x's and I have 2 x's, so I have 5 x's. Okay, but if I go to this next problem here, this one, I have 3x squared plus 2x. these are different. Even though they both have x's, this one has x squared and this one just has an x. And so I can't put those together. They're not the same thing. I can't actually put them together. So my answer here, there is no simplifying we can do. This is just 3x squared plus 2x. You can't do anything else. For this next one here, x squared and x squared, now they are the same thing, so I can put them together. I have 3x squareds plus 2x squareds, that's 5x squareds. So I just really want to point out that you have to be careful in cases like this. If they're not the exact exponent also, besides just the variable, but the exact exponent, you cannot add or subtract them. So the very last part, this should be pretty easy for us, is we're adding and subtracting polynomials. So if you notice here, I've got 3x cubed plus 2x squared minus x minus 7 plus x cubed minus 10x squared plus 8. So basically what you're doing is you're just looking at like terms and adding them together. So this would be a plus sign right here. Okay, so if I'm going to add them together, 3x cubed plus x cubed would be 4x cubed. 2x squared minus 10x squared. I know I just said minus, but remember that plus sign isn't going to change anything, so it's still going to be a minus because of that minus in front. So 2x squared minus 10x squared would be minus 8x squared. Negative x, there is no x over here, so it's just going to be minus x still. And then negative 7 plus 8 would be plus 1. This really should be pretty simple, pretty straightforward. Hopefully you won't have any difficulties with this. And so on this next one, I have 9x cubed plus, this is adding again, so I'm going to add. There is nothing to add it to because there is no x cubed over there, so it's 9x cubed. And then this one, the first one, has no x squared, but this one does have an x squared, so it's plus 5x squared. Now when I look at the x's, they actually do have something in common. So negative 2x plus 12x is plus 10x. And then 1 minus 4 would be negative 3, so that would be my answer. Now, where it gets a little bit more tricky and where you might have problems is when you're subtracting. Because when you're subtracting, just like when we did with the complex numbers before, that minus sign needs to be distributed amongst all of these things. So I usually rewrite everything. So I have 8x cubed minus 3x squared minus 2x plus 9. And then I'm going to distribute that minus sign. So minus 2x cubed minus 6x squared plus x minus 1. And so then I can combine my like terms now. I don't have to worry about distributing anything. 8x cubed minus 2x cubed is 6x cubed. We have negative 3x squared minus 6x squared would be minus 9x squared. Negative 2x plus x would be minus 1x. And then plus 9 minus 1 would be plus 8.